Forms of linear equations. So the first form that we've already talked about is slope-intercept form. That is in y equals mx plus b. So m is your slope, which is your rise over run, and b is your y-intercept. It is where you start on the x-axis. So if we had an equation like y equals 2x minus 3, that means the slope is 2 or 2 over 1, and the y-intercept is 3. So you can graph it from a slope-intercept form. Another form of a linear equation is standard form. So standard form is ax plus by equals c. Now there are things that are very specific about a, b, and c. First of all, a, b, and c have to be whole numbers. They cannot be fractions. So we will get to where there is a fraction and we have to clear our fractions. And the other thing is that a has to be positive. So if a ends up being negative in the middle of your solving, you would multiply everything by -1 to make it a positive. Now, if you're asked to graph from a standard form, there's two different ways this can be done. You can either graph with intercepts, or you can isolate y. So I'm going to show you both ways. So let's just say I have the equation 2x minus 3y equals 12. First, I'm going to show you with intercepts. So at the x-intercept, y equals 0. So I'm going to say if y equals 0, well then the minus 3y is gone. And it says 2x equals 12. If I divide both sides by 2, x equals 6. So that means that on the x-axis at 6, there's a dot. That's my first intercept. For the y-intercept, x equals 0. So that means now the x term is gone and it says -3y equals 12. If I divide both sides by -3, I get y equals -4. So on the y-axis, I'm going to put a dot at -4, and then I can graph my line. Now, if you do not prefer that, you could have also taken the original equation and isolated y. So in 2x minus 3y equals 12, if I want to get y by itself, I would first subtract 2x from both sides. I'd get -3y equals -2x plus 12. And then I would divide everything by -3. If it's not a whole number, leave it as a fraction for the slope. So negative divided by a negative is a positive. So we have 2/3 x minus 4. Now if we look at the way we already graphed, the y-intercept is -4, which is where we started. My slope is up 2 over 3. So if I was a little more accurate, it would be correct. So if I did up 2 over 3, from there, 1, 2, 3, it is the same line. If I had graph paper, it would look better. So it doesn't matter which form you prefer, intercepts or isolating y, that is how you would graph from standard form. Now slope-intercept form is a slightly different form. So what you are given is a point, and your point is going to be in the terms of x sub 1 comma y sub 1. The subnumbers are not anything mathematical, it's just labeling. It's the one point that you know, and you're given a slope m. So when you plug in your information into this equation, you're going to put your m form, your m number, right here in the front of parentheses. Then you're going to subtract the x value of the point, and then add the y value at the end. Now, if for some reason, let's just say like it was -1 comma 3, and your slope was 2, then your equation would be y equals m is 2, x minus x sub 1 is -1, and you're going to have a minus a negative here, so it becomes a positive, and then plus 3. So you do have to be careful with your negatives. Another form of this equation that you will see is this one right here. The only difference is that they took the y sub 1 and put it on the left side. I find the original equation a lot more handy. It's a lot easier to use, and you will be seeing other equations in the future like quadratics and absolute values that have very similar formatting as y equals m times x minus x sub 1 plus y sub 1. Now, if you're going to graph it, there's a very nice, easy way to graph this because you're given a point and a slope. So one of the ways that you can graph this is to identify the slope and the one point that you are given. So if my equation is y equals 2 times x minus 1 plus 3, my slope is 2, because that's the number in front of parentheses. The point is, it's always the opposite of the x value, opposite of the one that's with the x value. Opposite. So it's going to be a positive 1, comma, 3. So this always just stays the same. So if I wanted to graph this, I could first start at the point 1, comma 3. So I'm going to go over 1, up 3. I'm going to put a dot. So that's my point. And then from my point, I'm going to create my slope triangle of 2 over 1. So I'm going to go up 2 and over 1. And there's my line. Now, a second way that you could also do that is if you isolate y, which basically means taking your point slope equation, distributing and collecting like terms. So if I distributed, I'd get 2x minus 2 plus 3. Combining like terms gives us 2x plus 1. If you look at my graph, it's pretty accurate. It crosses the y-axis at 1, and now we know it has a slope of up 2 over 1 because that's how we created our graph. Now, there are specific types of lines, they're called constant functions, that are missing a variable. So the first one is a vertical line. So if you have a vertical line, it's going to be in the form of x equals k, where k is just some constant number. So the way that you do this is for x equals 2, on the x-axis, I'm going to go to 2, 1, 2. And I'm going to go straight up and down, which is the opposite direction of the x-axis. That is a vertical line going through x equals 2, and it is completely graphed and done. Similarly, with the horizontal line, it is in the form of y equals k, so y equals some constant number. If I wanted to graph y equals negative 3, I'm going to go to negative 3 on the y-axis, and I'm going to draw a horizontal line, or the other direction, opposite of the y-axis, and it goes straight across, and you're done graphing. Now, if you have two lines, and you know that they're parallel, which means they're running in the same direction and they never cross, you know that those two lines have the same slope. So parallel lines always have the same slope. So let's just say I wanted to write an equation that is parallel to y equals 1/2 x minus 3. I first have to identify the slope. So the slope for this is 1/2. So an equation of a line that is parallel to it is also going to start off with y equals 1/2 x. All I have to do is make a different y-intercept. So I can make it anything. I'm going to make it plus 5. Now the symbol is that looks like two parallel lines. It literally looks like a picture of two parallel lines. So we could have written this as y equals 1/2 x minus 3 is parallel to y equals 1/2 x plus 5 with that symbol in the between. Now a perpendicular lines cross at a 90-degree angle, and their slopes are negative reciprocals. Now remember, a reciprocal is when you take your fraction and reverse the numerator and denominator. So the first thing I'm going to do is find my slope, which is 5, also known as 5 over 1. The negative reciprocal means it's the opposite sign and the numerator and denominator are switched, which means my new slope needs to be a 1 over 5 flipped over, and it needs to be negative because the other one is positive. So my equation needs to start off with y equals negative 1/5 x, and I can have the same y-intercept for a perpendicular line. It really doesn't matter. I'm just going to make mine -2. So the symbol for a perpendicular line is actually a picture of perpendicular lines, and it looks like an upside down T. So we can do y equals 5x minus 1 is perpendicular to y equals negative 1/5 x minus 2. There's my perpendicular symbol. Okay, we're going to write a couple of equations given specific information. So this first one, we're going to be practicing writing things in standard form. Write the standard form of the line with a slope of 3 and a y-intercept of 2. So what we're given is a slope and a y-intercept. The equation that best suits us is then y equals mx plus b, because m is the slope and b is the y-intercept. So if our slope is 3, it's going to start off with y equals 3x. And if our y-intercept is negative 2, it's going to end at negative 2. However, the question is asking us to write this in standard form. So if you remember, in standard form, it is ax plus by equals c. So the first thing I need to do is get the x's and y's on the same side of the equation. The c, which is the constant, a number by itself, is on the right side all by itself. So I'm going to leave the negative 2. I'm going to subtract 3x from both sides. And I'm going to put my x first. It's in alphabetical order, x then y. So negative 3x plus y equals negative 2. But one more thing about a, b, and c, other than the fact that they can't be fractions, is a has to be positive. So if I multiply everything by negative 1, I can make a positive, and now it is 3x minus y equals 2. So this becomes the standard form of that information. Okay, if I just asked you to take the equation y equals 1/2 x minus 4 and write it in standard form, my first step is to get the x's and y's on the same side. So I'm going to subtract 1/2 x from both sides, and I'm going to get negative 1/2 x plus y equals negative 4. Now there are two problems with this problem so far. The number in front of x cannot be negative, and it cannot be a fraction. So the first thing is I want to get rid of the fraction. If you multiply by the denominator, which is a 2, I'll get rid of that fraction. Half of 2 is 1. But if I also multiply it by a negative, I'll deal with my negative issue. What you need to remember is if I'm going to multiply the first term by negative 2, I need to multiply all of the terms by negative 2. It's like an all or nothing thing. So negative 2 times negative 1/2, half of 2 is 1, so it's just an x because a negative times a negative is a positive. Negative 2 times y is negative 2y, and negative 2 times negative 4 is a positive 8. So here's my standard form answer for that problem. Okay, write the standard form of a line with a slope of 4 and goes through the point 1, 2. So let's look at what information we have. We're given the slope and we're given a point. Well, that means using our point slope form, which is y equals m times x minus x sub 1 plus y sub 1 is what's going to be the most useful. So I'm going to put my 4 where m is, and I'm going to put my x and y values where the x sub 1 and y sub 1 are. So I'm going to have y equals 4 parentheses x minus 1, that's the x value, plus 2, which is the y value. Now I need to make sure that I do finish my problem. Be very careful with reading the instructions. Some ask for point slope form, some ask for standard form. This one's asking for standard form. So I need to first distribute, because I can't have parentheses there. Y equals 4x minus 4 plus 2. I'm going to combine like terms. So y equals 4x minus 2, combine those. And next, I need to get my variables on the same side. So I'm going to subtract 4x from both sides. And I'm going to get negative 4x plus y equals negative 2. Now I'm almost done. However, my x coefficient is negative. So I'm going to multiply everything by a negative 1, which is effectively just changing the sign of everything. Negatives become positives, positives become negatives. And there's my final answer. Okay, 3 more problems. Write the equation of a line that goes through the point 1, 3 and 4, 6 in point slope form. Okay, this one's nice because it's going to be point slope form. Well, I'm only given 2 points. I don't have a slope. So the first thing I need to do is find the slope. So remember that if we're given 2 points, it's like one of them is x sub 1, y sub 1, and the other one is x sub 2, y sub 2. And the way that you find your slope, it's the change in y over the change in x. So I'm going to subtract my y's over subtract my x's. So if I look at that in terms of numbers, I'm going to go 6 minus 3, because those are the y values, over 4 minus 1, those are the x values. So 6 minus 3 is 3, 4 minus 1 is also 3, so that gives us a slope of 1. Now, with finding an equation, I have the slope and I have 2 points. You only need 1, and it's your choice as to which one you want to choose. So for absolutely no reason, I'm going to choose the first one. So if I plug in my information into the point slope form equation, I'm going to have y equals 1 parentheses, and if you don't have the 1 there, that's totally fine, because multiplying something by 1 doesn't change it. X minus, and this 1 comes from the point, plus 3. So this one came from the slope right there. The other one came from the point. And since that question asked for it to be in point slope form, we're done. Okay, last 2 problems. Write the equation of the line in point slope form, which is really nice, it'll make it easier for us, that goes through the point -4, -8 and is parallel to y equals 3x plus 10. So we have to figure out a little bit of information on our own. The definition of parallel lines is that they have the same slope. So if this equation is y equals 3x plus 1, its slope is 3, and a parallel line will also have a slope of 3. So now I have all the information I need. I know my point and I know my slope. So I can plug it into the point slope form and have y equals, slope is 3, x minus -4, which makes that a positive, plus a -8. So plus a negative is just minus. So if I simplified that, it'd be 3 times x plus 4 plus 8. Okay, last problem. Write the equation of the line in point slope form that goes through the point 10, 14 and is perpendicular to y equals -2/3 x plus 7. Okay, the slope of this line is -2/3. Perpendicular slopes are negative reciprocals, which means the slope I'm looking for is the reciprocal of 2/3, that makes it 3/2, and the opposite sign, since that's the original line is a negative slope, this new line is a positive slope. So now I have all my information, and I can plug it into my point slope form equation, and I'm going to have y equals 3/2 x minus 10 plus 14. And that is the equation of the perpendicular line that goes to the point 10, 14.